שאלות אחרות.
פתחתי, ואנחנו מקליטים.
בסדר.
recording the session, and it will be available in the blog section of our website, and you will be able to find it there. With that, I would like to introduce our presenters for today. We have here Amir Peleg, which is our founder and CEO. We are talking today about the challenges of water utilities, and obviously Amir has been talking to utilities in over 10 years and knows very well their challenges. Also, we have Udi Geismar, which is our VP of Enterprise Solutions, and among his other responsibilities in Takadu, he's also in charge of our customer success group, which helps our customers with the deployment and usage of the Takadu technology. So also very familiar with challenges. And without further ado, I will turn it to Amir to begin. Good luck to all of us.
Thank you, Anat. And welcome everyone to this webinar of Takadu. And we wanted to talk about the hidden challenges of water utilities. And indeed, as Anat said, this is based on more than a decade that we are active in the field with the central event management solution, and dealing and talking and deploying our solution with many types of water utilities, small and large, urban and rural. What we saw in the last decade, there is a shift from the obvious, the low-hanging fruit of everybody talking about leakage and water loss and non-revenue water, to a bit more of deeper challenges, things that you just cannot see on top of the surface because it has to do with data, it has to do with operational efficiency, dealing with customer satisfaction, how do you transfer, how do you retain your knowledge in the organization, how do you impact your planning and predictive maintenance. I think what we have witnessed is that through those years, we saw how change of processes and using data in a more rigid way shifted the focus to more challenges, to hidden challenges. They're all important. You cannot create a smart utility, you cannot create an optimal or an efficient utility without tackling all those challenges. And in a way, I'll just use some sort of a scientific term that all those dots are connected. You cannot solve one and expect that everything else will be resolved. You have to deal with all of them together. And just as a nice phrase, which I like to use, this greatest enemy of knowledge is the illusion of knowledge, it's not the ignorance. And for me, the analogy in the water sector was about data and sensors. I came across many cases that utilities thought that if they bought few smart meters or few sensors and some telemetry, and now they're collecting data, their problems are solved. And I think this is a bit of an illusion because this is only the beginning of that journey to solve those challenges. So let's start. And obviously the first, and I'm not going to talk a lot about it, myself and Udi will share some of those topics. But the first thing is obviously the non-revenue water topic and water loss and leakage and bursts. Even though this is really on the surface, this is still important. It is a low-hanging fruit, and it is still important. You can see more and more focus around that topic around the world, not just in water scarcity territories, but all over the place. And I think the topic is really to tackle all the dimensions of non-revenue water. The challenge is to have early detection. And when you detect it, what we saw is customers were telling us, we would like you to quantify the water loss. Tell us exactly when it started and tell us exactly how big it is and how much money we are losing per hour, per day, so that we can prioritize. Then obviously there is a whole issue of unauthorized consumptions. What happens when the meter is not doing its job, or if you have underbilling in large consumers. And you know, whenever we deploy central event management, we always come across cases that we are deploying in a certain date, and then we see a whole history of leaks that have started a month ago, 6 months ago, or even a year ago. And even in one case in Australia, we have a quote here, and in that specific case, we know that with time, they've learned that they were doing monthly meetings in order to prioritize different DMAs, in order to create some quantifications of in which zones, in which areas they had more problems, not necessarily just higher leakage, but just even more, the frequency of those leaks was higher, and they wanted to impact how they do their leakage surveys or even asset replacement. Udi?
Thank you, Amir. Since in this webinar, our objective is to help our audience to build or to list all their checklist of requirements, I will complement all the topics that you present with examples. All these examples are based on our customers' experience. We are not necessarily going to mention names here, but they are, everything is based on the experience of our customers from Australia, from Europe, from Americas, and also based on public information. We hope that with the combination of the challenges and the examples, everyone will be able to create a good list of requirements for their future use. So the first example here is of physical loss. This is a hidden leak the system detected. It's a relatively large leak of 1.2 megaliter per day. As you can see from the picture, from the photo, the leak is very close to the bay and theoretically could remain for practically forever until it would burst and someone would notice it on the surface. In addition to detection of the leak, the solution enables to manage all the activities that are related to the repair, and also to record all the activities and the changes that the event is going throughout its life cycle for future debrief, learning, and other reporting uses. Next one, please. The next example is of a relatively large unauthorized consumption, and in this case it's close to 0.5 megaliter. And in this case, the system helps to detect and manage the an apparent water loss. Next. Another example of apparent loss is where the meter is not functioning well, the meter that is used to measure the consumption. And in this case, it's a meter that is related to a large consumer. And as we can see from the graph, the meter functions deteriorates slowly over a period of time. And when the meter doesn't work well, you as a utility don't bill your customer accurately based on their true consumption. And with such a solution, you can detect, or you should expect to detect, this kind of cases and help you fix the meters and return back to bill your customers correctly. Next.
Thanks, Udi. And now to those 5 hidden challenges that we named the webinar about. And we believe that while we are presenting them, I would like each and every one of you to always try to connect those dots, how they are all linked to each other. And data is maybe the fundamental element of any smart network, and that's the basis for everything, because as we all know, if you don't measure it, you don't really know it. And if you want to understand leakage, you have to measure something in order to detect those things. So in terms of data, I think the basic question is, how do you really know your data? Do you know your data? Do you know if you have good data? Do you know if you have the integrity of the data, the availability of your data? Without reading the slide, you can all do that yourself. But we came across many examples that when we deployed central event management solution, customer told us that they have X number of sensors and those are great, or they've been brand new since a year or 2 years. And it happens more than once that we deploy the solution and oops, 30% of the data was missing, or 50% of the sensors in another case were not transmitting data in a good manner. So everything has to be measured. You have to understand, you have to measure the quality of the data. Do you have a lot of gaps in the data? Fix those gaps. How do you deal with multiple type of sensors? Can you easily scale and generate some sort of a mini data tsunami and still deal with this data and grade and rank in an objective way the quality of your data? And that's what central event management provides, because when you see the quality of the data and how do you translate quality of data into quality of DMAs, are those DMAs have good patterns, are closed, measuring closed supply zones, you could see that from deployment phase through the first few months, almost all our deployments have shown an improvement in the data availability, data integrity, and so on and so forth. And that obviously helps to detect and to manage all the network incidents. Udi?
Yeah. You're so correct, Amir. And before we speak about certain values and benefits from the system, there's something that happens immediately when you turn on the switch is visibility, and then it's one truth across the board. And in this case, when we speak about the data quality, this is an example of a customer that it took them something like 6 months from the minute they went live until they stabilized their data quality and not start gaining, but stabilize the data quality to a level that was adequate according to their expectations. And when we speak about data quality, there are several aspects. So first of all, we speak about the meters. So do we know if all the meters are working? Are they calibrated well? Are they in the right resolution? You know, in some DMAs, you have more than one sensor, and all of them need to measure the data more or less in the same resolution and same timing. Does this happen? What about transmitting the data so they can find the meters, but if they are not sending the data to the central repository, then it's like the meter is not working. There are cases that there are not enough meters in an area, so not all the ins and outs, inlets or outlets of the water in the DMA are measured. And even when you measure all the data, it's not necessarily that the data is at the right quality. Right quality means that it has a good pattern, that you can use it as a good basis to create, to generate and detect events. Next.
Next in line is probably maybe almost the holy grail of everything is how do you make your operation more efficient? And how does everything connects to being, to have operational efficiency in dealing with network incidents, in dealing with network events. So essentially what we would like and customers would like is to achieve more with less. You want to have the same level of leakage with less resources. You want to achieve higher uptime of the network with the same level of maintenance and the same investments in the network. And if I'll take another example, you want to have less firefighting. There is a lot of criticism about water utilities, that the mentality is always to do firefighting. A customer complains that they see water in the street, and you send someone to fix it. And you want to deal with it before it gets into a burst and customer will complain. You want to know about it and fix it in lower amount of resources. The same also from a managerial point of view. You want to deal with the important stuff and not necessarily just with the urgent stuff. As one of our clients told me once, that after deploying central event management, it allowed him to really prioritize and focus on the important elements. It has to do with communication. You have different departments, you have different silos, and you want to communicate with them on a single database about what's going on in the network. So that visibility into a single layer of truth will help you to communicate between different departments. And I'll just take one example I heard from Australia, is the fact that even the repair teams, the field teams, could log to the same system as the people in the control center and as the managers. That helps to even increase the morale, the satisfaction of those repair teams, because they could actually see the impact of their work. And once they are happier, everything else is better. So it's about communication. It's about putting everything in one central system that will allow you to deal with the important stuff and prioritize. It is about reducing the repair cycle. We have one example, again, from a large utility of a couple of thousands of kilometers of mains, that they managed to reduce the repair cycle by about 60%, which means that they could solve most of their events in about 1/3 of the time and resources. And when you connect all those things, you are becoming way more efficient. You can really achieve higher uptime, lower revenue with the same level of resources. Udi?
Yes. So here I'll describe 3 examples of different customers that summarize their efficiency gains or the effectiveness of their operation after the first term of using the system, after 1 or 2 years of using the system. And this is the first example, the first customer, and we see that they reported about 3 main improvements around their operation. First of all, the time that their users need in order to use the system and detect and manage all the events reduced from 5 hours to 2 hours per shift, meaning they need less people in the back office. They reduced their leak detection from a service from 4 kilometers to 3 kilometers per leak. So they need less people, or they can do it faster. They detect the leaks faster in the field. And now, since they shifted their most of their operation from being reactive to proactive, they could also reduce the repair cost from $1,000 to $500 per hidden leak. And last but not least is from the same reason they moved to be more proactive, they reduced the collateral damage by 10%. Next, please. Here is another customer that reported that since they are more efficient, they could reduce drastically the amount of breach cases, breaches where water are flowing between adjacent areas. And through this avoidance or reduction of breach cases, they could save lots of energy and avoid usage of field service employees and back office employees. Next one. The third customer reports, again, about the same area of improvement, and here we see that they could reduce their overall operational cost and being more accurate with their dispatching. Amir.
Okay, thanks, Udi. The next topic is about customer satisfaction. This is actually relatively new in the industry. When I founded Takadu about 10, 11 years ago, most utilities were talking about connections. These days, you started to see a shift in language. People are talking about customer satisfaction. Customers are people with identity, with needs, with easy access to communication, to social media. Suddenly there is a growing pressure to provide much better service. And that's not necessarily the case on average of customer satisfaction. And that is where using a central event management actually helps a lot to improve customer satisfaction, because you can actually influence how you are dealing with problems, with incidents. You are shortening the repair cycle, you're improving the network uptime. You actually know about problems before customer will complain. We had one case, I think it was in Australia, where the records of Takadu Central Event Management were used in court because the regulator took one of the utilities to court because they violated the fact that customer complained before they knew about it. And they proved that they actually knew about it, it was detected, and it was in the process of being repaired. So we strongly believe that customer satisfaction and improving customer service is all linked to knowing about problem, being more efficient in dealing with them, and eventually applying or keeping the regulation. Udi.
So again, here we'll speak about, or we describe two examples of being or improvement of customer service. And as you mentioned, Amir, customer service is tightly coupled with customer satisfaction. And here we see the same customer that we used in the previous example, one of them. Here they report also improvement about 3 KPIs that are related to customer service. They speak about themselves. I don't need to read them. Next, please. And here is an example from a regulation in Italy, where the regulator drives the utilities to improve their customer service through an improvement of the network uptime. And we see that if it's too low, they drive for a constant and consistent improvement. And if it's good enough, they expect them to retain the same levels. Amir.
Okay. Next is about data and knowledge retention. That is a tricky one. That is tricky one because for many years, the water sector was known that you need to have that top expert water engineer that is working with your network for many, many years, and he knows everything. It is still the case in most cases. And you do not see a lot of young generation joining the industry. How do you do with hiring lower skilled workforce? You know, the statistics shows, or the numbers, the facts actually shows that about 1/3 of all the workforce in the US water sector will be entitled to a retirement in the next 10 years. And if I'm not mistaken, in the UK, the number is even higher. It's something like 50%. So how do you attract young, lower skilled workforce? How do you cope with the fact that in today's world, it's not like 20 or 30 years ago, there is a higher pace of change. Everybody wants to move on in their career every 5 to 10 years. So you do not retain all their knowledge. You have to move to a system that will retain that knowledge, that it will be user-friendly, that anybody can use that system, that will keep all the logs of all the historical events and incidents so that you can learn from that even next year or following that. And I think that the best example that I could use for this topic is what happened in this year. Unfortunately, you know, 2020 was all painted with COVID and Corona all over the world. And we saw, and then there is even a nice video clip that we produced recently, is we saw how easy it was for all our customers to shift from working in the office in their well-organized control room to move to work from home. And if one of their top experts was quarantined because of COVID, they could actually assign the same task to any young engineer that they employed, because he could easily adopt, he could easily learn what are the topics, how to operate the system, and in a way retain the same level of knowledge of how to prioritize, what is the visibility in the network, and so on and so forth. So this is a major issue for the whole industry. And we believe that through central event management, this is a good way to solve it. Last of those hidden challenges is predictive maintenance and planning even. And we think that this is all about how do you shift from collecting all the data, the tactical level of data about incidents and events, what's wrong in the system, what's wrong in the network, what assets are failing, and how do you translate that into a bit of a long-term plan, into predictive maintenance type of prioritization? How do you decide upon that about CapEx investments? And one of the stories I like to share is that in Australia, one of our utilities, one of the customers, had multiple cases of PRV failures. And in this case, he detected a lot of PRV failures. And over time, through reports and through all the quantification about those issues, he could actually draw a conclusion. What was the problem? And he could do the optimized maintenance to those assets. And probably in the year after that, he saw that number goes to zero almost. Udi?
Yes, couple of more challenges or more options to use the ample of data that such a solution collects over time is to help with practical decisions such as should we resize and split a DMA into two smaller areas? Where do we miss a meter in a DMA? And if so, add that one or more meters there. Maybe based on reviewing the information, we can take additional decisions about proactive leak detections in some of those areas. All these kind of decisions are based on analysis of reports and special processes that you should expect to have based on the data that the system collects constantly. Mir.
Okay, so we're close to the end. So I just want to recap and just review quickly those challenges that we've listed. The one that were obvious, the one that are above the sea level, the above water, the tip of the iceberg, which everybody talks about, leaks and bursts and hidden leaks and all the non-revenue water issues. But that's only the low-hanging fruit. I think deeper you'll see all those challenges that will lead a utility to become smarter, to become more efficient. It starts with data. It goes into processes. How do you want to become more efficient? It ends with the holy grail of making your customers satisfied, even though it's a non-competitive industry. You want to make sure that your customers are happy with your operation. How do you maintain, how do you retain the knowledge? It's all part of the same dilemma of having an automated remote monitoring and be able to even hire a lower skilled employee and make sure that he is an expert in a few weeks. And how does everything also impact the planning and predictive maintenance? And in a nice graphical way, you know, if we are gaining more and more knowledge, at the end of the day, we have to translate that knowledge, not just from us, the human beings, but also into automated processes, whether those are use any big data passwords or event management or reporting module. But you have to make sure that those are working in sync, that you're gaining more knowledge, you have more data, there will be even more data in the years to come, and that they will all be linked back to sufficient processes. And I actually like to call it the PPT paradigm, the people, processes, and technology. The technology actually comes last, but you have to make sure that all those dots and all those challenges are being tackled in one heuristic view and not just to go after the low-hanging fruit. And just my last slide, I like to be very positive, and I like this image because it somehow creates a nice shine. And in the spirit of the Corona year, I will end with a small text saying, think positive and test negative. That's a wish for everyone worldwide. So now maybe we can open the floor to questions.
Thank you, Amir and Udi. It was very interesting. I want to remind everyone that you can send the questions in the Q&A section at the bottom of the screen. We left a lot of time, half an hour for questions, so please don't hesitate to send as many questions as you would like. I would start by reading you the questions. One question is asking, what other kinds of data do you see utilities are using? What types of data
So I will take that. We mostly obviously is flow and pressure, but you also see more and more utilities starting to implement real-time water quality type of sensors. You start to see more and more sensors in the wastewater side. You start to see reservoir being measured and so on. But most of them are flow and pressure.
Thank you. Another question, do you see many utilities implementing district metered areas, DMAs? Where are they vastly adopted?
Udi?
We actually see it everywhere. I can't say that in one geography it's more common. It's very common in Australia, in Europe. In some cases, yes and no. I can still see that some utilities adopt it over time. In Latin America, it's very common as well. In North America, I think that they are starting now. We see it also picking up in Canada.
There is one additional question which is related to this, so I will jump to it for a second. What are the benefits of implementing the DMAs, the district metered areas?
The methodology around DMAs is to split the network into smaller supply zones, such that it's easier to trace a leak in the zone rather than in the entire network. So with that in mind, utilities that adopt this solution are a little bit more efficient in their way of detecting leaks. And once you do that, it enables you to be more accurate and more efficient in your entire measuring of your KPIs in the network. So it's also related to pressure, to measuring consumption of larger consumers, water quality, and other type of data that customers are measuring.
Okay, great, thank you. How do you overcome the challenges of limited number of data gathering sensors in water distribution system, particularly in North America?
I'll take that. It's a very good question. And indeed, when utilities do not have data sources, we are blind. But the same is also true for the utility itself, if there is a limited number of data gathering sensors or zero. But my answer is that even with limited number of data sensors or any number of sensors, one must start using central event management and some analytics, because with this good food will come the appetite. And we've seen cases where utilities started with X number of sensors and they've collected the data like every 6 hours. And a couple of years later, they have something like 4 times the number of sensors, logging the data every minute and transmitting the data to us every 10 minutes. So what you see is this evolution of appetite, that once you understand the power of using the data in the right way, the price of sensors and the cost of communication is so low these days that it's just worth to put more sensors and with higher frequency of logging and transmitting the data.
Next question. From your experience with your customers, what do they do with data related to water quality? Do they do some kind of analysis?
Yes, they do. Like any sensors, you have to, first of all, make sure that the sensor is right, that no gaps and that the patterns are right and the data integrity and the data availability is there. And obviously using some analysis in order to detect problems related to water quality, whether those are chlorine or turbidity in an early stage and not just when it crosses a certain threshold. Typically, you have minimum and maximum threshold, but that's not good enough because when it reached that threshold, maybe it's too late. And if you lower the threshold, then it could be also exposed to some spikes in the data. So you have to do analysis on top of any data type.
Okay, thank you. Do you consider pressure management as a key priority to extend life of assets?
I think pressure management is important to extend life of asset, but it is only just one dimension. When you manage your network, water pressure is just one dimension of everything, and not just, and sometimes it is important, but it's not everything. So we are connected to several pressure management solutions. They are integrated with central event management. So the answer is yes, but it's only a partial view of keeping assets in good health.
Examples of pressure differences or pressure-related events or incidents can imply on problems of such as leaks, or in other cases where PRVs are measuring pressure as well, and when they start to deteriorate, it gives you a good hint that something bad is going to happen in the downstream of the PRV. So these are just two examples that are related to pressure. There are other examples. So pressure is definitely one of the factors that we use in our system to as a means to measure or monitor the operation or the network operation.
Someone is writing, thank you for this webinar and the presentation. Does CEM manages data from water flow and pressure or something else?
So central event managers is not just to manage data. We are managing events and incidents in the network. And yes, we can comply with water flow data and pressure data, but also with any other type of data sources that you're using.
Okay, someone is asking how quickly can the rollout happen?
So our standard project deployment with the customer takes 2 months. It can be a little bit faster or a little bit slower, depends on the readiness of the customer to provide the information that we need. But if the customer is ready, then from kickoff to production usage, it's 8 weeks, so something like 2 months.
How does Takadu carry out leakage studies? Is a link to the commercial system necessary?
No, we don't need to have a link to the commercial system, although it can complement the other information that we use. In order to learn about leakage, it's enough for us to have good information about the flow and pressure sensors that are spread in the DMAs or in the network.
How are you gathering the data from the meters? Do you need to install your software on site?
So the answer is no, we do not have any piece of software on premise, on site. Usually data is being transmitted to the cloud by the utility, either directly from the SCADA or from any other type of data gathering platform or data historian. And I will even put a comment that in the next few years, with all the IoT revolution and all those very smart sensors that are coming out with a lot of edge computing, and even inside the sensor, you'll have some analytics, all of them are coming with some solutions that will collect the data. You have IoT device management platform these days. So we don't need to go over areas where the hardware vendors are providing solution both in the sensors, in the data collection, and repository. So we're getting the data directly from those layers.
This is also related. The next question, Takadu works in the question is whether Takadu works in the cloud, which you answered, is a corporative online system.
Udi?
I don't know exactly what you mean with cooperative online system, but eventually it's an enterprise solution used by the team that manages the network operation, a control room or something equivalent, like ERP, CRM, any other call center, any other production system that you use in your shop floor.
Okay. The next question, you talked about the quality of data. How do you see the measure equipments today of flow and pressure, and how do you think it will or could improve?
So, I don't want to judge any specific vendor or any specific technology, but I think it's almost like, the improvement of any devices, any measurement devices, measuring technology. You see a constant improvement in both flow measurement and pressure measurement, both in the size and also in the way to install it, in its price point, in the reliability of those devices. I have high expectations that this will improve drastically in the next 10 years. I don't think the horizon of 5 years is enough. Prices will go down. With all the IoT, you'll see more and more smaller sensors that can do multiple things with a lower price point. You could see already that even in the simple smart meters, the residential smart meters, a very heavily populated domain with all the Itrons and Sensus, etc. Even there, you have unique solutions today that are cutting the price point by half and generating even double the battery time. So, but this will even improve, or actually this will even increase the need for solutions like central event management, because the more data sources you will have, and if you will think that they are cheaper and you can plug in or throw some more sensors in your network, you'll have to deal with massive amount of data, and you need to do it in a consistent way.
How easy is nowadays to connect Takadu CEM with other software as maintenance and work order system or asset management systems?
Woody?
Yeah, so it's very easy, and a lot of our customers these days are connecting their work orders with Takadu. The reason they do it is in order to double check or to validate the information they see from different dimensions or different solutions under the same case, under the same event, to see that there are no false cases, or to see that to have some explanations about some of the activities based on the information they see in other systems. It's very easy. It's as easy as it is to integrate the information from the sensors with Takadu. Just send the information to our FTP. We download it from there. You send it once a day or several times a day. It's very straightforward.
And I will even add to that question that even a topic like connecting to a call center was raised by a few customers. And we did it because a call center is another source of information, another source of valid data.
Next question, how do you detect flow increases? Looking at night flows?
So detecting any anomaly, flow increase, flow decrease, any change of the data, it's all about detecting anomalies. So it's all about looking at patterns, not just at the night line, not just at the night flow. You have to look, we can detect a flow increase even at noontime, because when you observe the patterns and when you generate predictions to how a DMA flow pattern should look like, if I talk specifically about flow, and we use few dozens of different prediction methods, and if you combine all those prediction methods and the statistical engine decide that there is an anomaly in the pattern, not in the specific value that could be just a spike, but an anomaly in the way the pattern of the flow looks like, that's when we are detecting that flow increase or decrease or any change, because we are observing patterns over time, not just during the night.
Amir, if I may complement what you described. So we encourage our customers to send us the data quite frequently, and quite frequently is something like once every hour. It can be more, but once every hour is fine. The time that it takes to analyze, to process the data that reaches our system takes us between half an hour, 40 minutes, something like that. And this means that if the system detects, or if the information that we receive now indicating about a leak or any other event, it's very likely that within an hour or so, the system will raise a flag and say, hey, we detected the leak. So it can happen in the middle of the night, in the middle of the day, or in any hour of the day.
The next question, is your system replacing a SCADA system?
So the simple answer is no, we are not replacing SCADA. We are usually a layer, central event management. It's supposed to be a layer on top of SCADA, getting data from the SCADA. I will just say that there is some sort of a notion in the industry with new IoT devices and IoT device management, there will be a reducing need for a SCADA to maintain the network itself. I'm not talking about treatment plans or any other type of operation. So there is some sort of a notion in the last couple of years that maybe SCADA will change its form and will not be called SCADA in the next few years, because SCADA stands for supervisory control and data acquisition. The whole thing about data acquisition will be meaningless in the IoT era.
Thank you. Does Takadu addresses also information about customers with smart meters? How?
So custom smart meters is optional for, it's not mandatory. And if the utility collects information about consumption from the smart meters, what we can do with it is to create a kind of a balance per each day or longer period between the consumption and the supply, and use it as another type of information to govern the water balance and the water consumption in each area.
Thank you. How do the CEM supporting knowledge? How does the CEM support knowledge retention? Would it learns more time by time?
Would it?
Yeah. So first of all, it learns from the experience, from the patterns, from the behavior over a period of time. This is one direction, but it's not only that. It also through recording and capturing of changes and user activities over a period of time, in order to being able to retrieve it and use it for reporting and analysis later on. But I think that the most important factors are related to being intuitively, or having an intuitive user interface, such that you don't need to to be an expert in order to use the system. You can study it very fast, and also by the fact that we embed into the functionality best practices. So the processes are already guiding you in order to take the right decision at any point of time, and watch your behavior as if you are almost an expert.
Thank you. Do you see any problems adopting cloud in different countries in terms of security concerns?
So the basic answer is it's getting less and less of a problem. I have two answers on that. One, in still very few cases, you have laws that prohibit utilities to use cloud service. Those are very, very few cases. And the second thing, it's very easy to prove these days that the security that we can present using Amazon Web Services, AWS, is by far better and higher in terms of the security, the level of security to any on-premise server.
Next question, would you agree that by studying the diurnal flow and pressure patterns, you can better determine the level of leakage than by traditionally integrated flow analysis and night flow analysis until IoT makes all the data available almost live for analysis?
I think that by studying the patterns and by making sure that, again, I'll go back to the data problem, that the data is in good shape and do not have too many holes and gaps in it. So yeah, you can actually determine the level of leakage better than any traditional just night flow, because both you can detect those things 24/7, you can estimate the level and the real quantity of water loss being lost until now and on a daily basis. You can prioritize what to tackle first. It's the grand scheme of things that allows you to have a much better management system and not just to measure nightline. And I think that it's not about waiting the IoT. I think it's about you have sufficient amount of data already today in some territories, in some countries. You just need to make sure that you're using all this data, because otherwise that investment in sensors and telemetry is a waste.
Thank you. We're starting to get closer to the end of the presentation, so I'm going to pick a few other questions. What about data from reservoirs level meters and outflows? Do you collect this data and analyze it?
Rudy?
Yes, we do. All the reservoirs are essential in order to realize the water balance in each area, each DMA. So they can be an input into the area, or they can feed other areas. So we have to know how much water are getting in and out of the reservoirs all the time.
Okay. Does Takadu work with the local field investigation company to better understand the network when implementing to a new network?
Takadu work with the local field investigation company to better understand the network. So it's the answer is strange, but that's how it works. We don't have to be experts about the local water network in order to configure our solution. Our customers are the experts. They know where the meters are and how each device, each asset behaves and its role in the operation. We request to provide us basic information about the network, such as the hierarchy of areas, DMAs, and higher level. all the meters that are installed and are being used in each DMA, and the role in the DMA, and in other areas if it's higher level than DMAs. That's it. We don't need to map all the areas, and we don't need information about all the other assets. We can use it, but it's not mandatory.
How many connections should be in one district metered area?
What's the size of a DMA? Huh? It varies, and it small, or we see that it's the numbers can be between few hundreds up to few thousands. On average, kind of golden number is around 3,000 connections in each DMA, and the length of something like 10 to 30 kilometers of pipe. But in our experience, we see that we have customers with much smaller and much larger DMAs. If I can just add one more point around it, I think that early next year, we plan to release a study that we made around the size of DMAs. So we will publish a document about examples of sizes and the impact on the value of the customer and the ability to be accurate with monitoring the network.
And I want just to add a comment that it also, and again, going back to the content of this webinar, there is always a nice question to be asked: what is better, a small DMA with lousy data or a larger DMA with very accurate data? So I think that the question is obvious. So it's the size of the DMA and the number of connections also relates to how good and what's the quality of the data that you're measuring in that DMA.
Okay, so we have time for one last question. Is the accuracy of the leak measurement affected by the amount of debris in the water piping? Would the software also be able to give an indication on the level debris in the piping and perhaps give the location, perhaps areas of high blockage?
I'm not sure I fully understand, but as far as the accuracy of the leak management is not necessarily affected by those conditions of the piping, because remember, we're using those measurements of the utility, and if they measure 1 or 2 inlets into the DMA and a couple of pressure loggers within the DMA, that's what we have, and that's the analysis we do. So, and if they need a higher accuracy of exactly the location, usually we are partnering with some acoustic loggers such as Aquarius Spectrum or Gutermann, which are good partners of ours, and hence you can actually use them in collaboration with Takadu so that you'll have a much higher accuracy of the exact location.
Okay, thank you very much, Amir and Udi. I'm afraid we don't have more time for more questions, and we couldn't answer everything. If you would like to send us your question through our website, through the email part over there, we'd be happy to continue a private discussion and answer any of your questions, or if you would like to set up a meeting or to discuss further, we're always available for that. I would like to thank everyone. As I mentioned at the beginning of the webinar, we have recorded this session. It will be available on our website in the blog section. Thank you all for joining us. Thank you, Udi and Amir.
And keep safe.
Thank you very much. Happy holidays.
Bye-bye.
Bye-bye. Thank you.
Bye-bye.